Hello everyone, welcome to this class. This is teacher Simon taking you through IGCSE Mathematics paper 0580/23 for May June 2025. This is part 1. Question 1. The probability of picking a green pen from a box is 0.17. Find the probability of not picking the green pen from the box. Of course, probability of picking something plus probability of not picking it is always equal to 1. So that means probability of not picking the green pen is going to be 1 minus the 0.17. 100 minus 17, you get 83. So that means here we get 0.83. Okay, then after that, question 2 is from angles. They are saying that ABCD is a quadrilateral, CDE is a straight line, CDE, this one here, AFB is an isosceles triangle. Find the value of X and the value of Y. Now, when we look at what we are having here, since this one is an isosceles triangle, that means the opposite sides to these, the opposite angles to these sides that are equal, even these angles are equal. So that means here we shall have also Y. So meaning we shall have Y plus Y, then plus 30. This one is equal to 180 degrees. So suppose they asked us of the geometric reasons we could give here. Angles in a triangle add up to 180 degrees. So first of all, we have this one as an isosceles triangle. And then we say angles in a triangle add up to 180 degrees. So this is 2y, which is equal to 180 minus 30. Then y would be equal to, this one gives us 150. Then we divide by 2. Then we get a 75. Then how about x? This one is a quadrilateral. So if this one is a quadrilateral, we need to get the angle here. Okay? After getting the angle here, then we'll be in position to get like to add all of these ones, and then we equate to 360 because angle sum of a quadrilateral is 360. So the first thing to do is to get 180 minus 104, which actually gives us 76. Here, what am I using? The geometrical reason here is angles on a straight line add up to 180 degrees. Angles on a straight line add up to 180 degrees. So this is 76 here. Now we can add these angles and we equate to 360. So we shall have x equal to 360 minus, there is a 70, there is a 74, and then there is also, no, it's actually 76 that we have just gotten, and then the other one is 130. 130. Okay, here angles in a quadrilateral add up to 360 degrees. Okay, this is 130 plus 70, that will be 200. Then this is 276. So we have 360 minus 276. Now here we are remaining with 24 to go to 300. Not so? Then there is a 60 here. So we shall get this 60, we add on the 24, then it will give us 84, not so? Yes, so this one becomes 84 degrees. So our x is 84 degrees and then our y is 75 degrees. Question 3 is coming from Symmetry. They're saying the diagram shows a pyramid ABCDE with a square base. M is the center of the square base. E is vertically above M. Write down the number of planes of symmetry in this pyramid. Now, you should know that a plane of symmetry passes through the lines of symmetry. Okay? It is formed by the lines of symmetry. A plane of symmetry is formed by lines of symmetry in the faces. Okay, so this one here, it being a square, this one is a line of symmetry, this one is a line of symmetry, this one is a line of symmetry, and also this one is a line of symmetry. You see that? Now, the planes of symmetry here, since this one is a square, the base is a square, then this one is equal to this, is equal to that, is equal to that. The slanting heights are all equal. Are we there? So now this simply implies that this one here, the triangles formed here by the triangles in these faces here, they are isosceles. So meaning the line of symmetry is the one that passes through here, in the middle here. Okay, so it comes, attaches there, then it joins this line of symmetry here. Okay, then it will join this line of symmetry here. You see that? Now that is one plane of symmetry. I've cut it into two. That is one. Then another one, let me use another color. I can have the one behind and the one facing me. Okay, this one here, this triangle here. Okay, this one here. So there is a line here in the middle that comes like this, that divides it into two. Okay, then it joins to this line of symmetry. Remember, the plane of symmetry is, okay, the plane of symmetry is formed by the lines of symmetry in the faces. Then again it connects with the one behind. You see that? That is another plane. So those are two. Now, I cut my pyramid this side, this way. Then I also cut it like this. Okay, those are two. Then which other lines of symmetry do we have? The other lines of symmetry we have are these ones here. Let me get another color. Now let me use blue. For the base, there is this line here. You remember? So that line there, then we shall cut through. Where? Yes, you just cut through longitudinally. Now this one will pass through this, and then also here. Then the other one is going to be through this one here, and then goes through here, then also comes like that. You cut it into those. So how many are those? I've used these different colors such that you can see the planes that we have. Okay, and what do we see here? We are having the blue one, the red one, we have the yellow one, and the green one. So those are 4. That means the planes of symmetry here are 4. And then B, using 2 of the letters A, B, C, D, E, and M, complete the statement about the pyramid. The axis of rotational symmetry passes through the points. The axis of rotational symmetry. Of course, this one has to pass through E and M. Okay. Rotational symmetry, you are going to rotate this one all around. Now, you will hold here. You will hold here. As simple as that. And then you can rotate this one all through. It has to be E and M, that vertical line here. That cuts this one into like that axis has to pass through. In other words, if you have that length, remember this one is a square. So because it is a square, and then let's say you pass through a road in the middle here, like this, then you can rotate this one. Okay, you can rotate it around it. So that's why it is passing through E and M. And if we are saying that rotational symmetry, it is going to produce, it can actually produce something like maybe a cone. Okay, something like that. So when you are rotating, it is forming something like that. You see? So it has to pass through this sharp end here and then the center. This is our center and then this one. So that's why I'm drawing a line like this. You see that? Such that you can be in position to get the what? The axis of rotation. So therefore, it has to pass through E and M. Question 4. The number of ice creams sold increases as the temperature increases. What type of correlation? This is a positive one. Okay, as simple as that, positive. If one entity increases and the other one also increases, that is a positive. If one reduces yet the other one increases, that becomes what? A negative. Question 5 is coming from transformations, and in IGCSE here we look at enlargement, rotation, reflection, and translation. Now part A, they are saying describe fully the single transformation that maps A onto B. I've already said that whenever they give you such a question, you look at the number of marks they have given. If the marks given here are 3, then you think about enlargement and rotation. Because if it is enlargement, you're going to tell us that it is enlargement, give us a scale factor of enlargement, and then the center of enlargement. When it comes to rotation, you tell us that it is rotation, give us the angle of rotation and the direction. For example, 90 degrees clockwise. You get it? And then the center of rotation. So now since this one is 3 marks, then these are the ones that we are looking at. Of course, if it is 2 marks, then that is either translation or reflection. So for this case, we are going to look at these 2, enlargement and then rotation. Then for rotation, the object and the image are the same size. Okay, they are congruent shapes, but for enlargement, one of them is bigger than the other. And when you look at this, we can see that A is smaller than B. So for us to get the so therefore this is enlargement, by the way. So let me just write, this is enlargement. Enlargement, tell us the scale factor. By scale factor, what? Enlargement by scale factor dash center, we also need it. So for us to get the center, the scale factor of enlargement, the scale factor is equal to image side length, then divide by the corresponding object side length, okay? The object side length, because these lengths are connected by a scale factor of enlargement. What I multiply this side with to get this one is the same that I multiply this with to get this other one, as well as this one here, okay? All right, now let's look at the scale factor of enlargement here. Which one is the image, which one is the object? They say that we are mapping triangle A onto B. So this is the image, B is the image, A is the object. So you get, when I look at this one here, I can take this diagonal here as 1 unit, then 2, then 3. Then here it is 1 unit. So I will say 3 over 1. That means the scale factor of enlargement is what? 3. So let me first put this one as a 3. Then to get the center of rotation, we draw lines. Draw lines through object points and corresponding image points. Okay, where they meet is the center of enlargement. Where they meet is the center of enlargement. As simple as that. So you get your ruler and then you draw all through. Okay, now this one here, the corresponding image is this one. So I just draw a line all through. Okay, so I'll come to this one here and I just draw all through. Don't just connect here and then here. Okay, then next, this one here, the corresponding one is here. Then we can get this and we draw all through. Just like that. Then we also now come to this one here and then this one. We do the same. Connecting them, then I just draw all through. Now, where these lines meet is the center of rotation, enlargement. Let me make these lines dotted such that they don't interfere with our diagram which was given, just to show that these are newly drawn. Okay, now we can easily see that these lines here have met at this point here, which is 1, 2. So the center is going to be 1, 2. So that is what we are supposed to have. So we have one mark here for enlargement, then the scale factor is 3, and then the center 1, 2. Okay, that is that. Then here's something I want to say about the scale factor of enlargement. The scale factor of enlargement is positive if the object and the image lie on the same side of the center of enlargement. Now you can see here, if this is the center of enlargement, the object is here and then the image is here. They are on the same side. But if the object was this side and then the image is this other side, then the two are on opposite sides of the center of enlargement. That means the scale factor there becomes a negative. Okay, so I wanted to clarify that one there. And also the scale factor of enlargement is going to be a whole number if the image is bigger than the object. And you can see that this image is bigger than the object. So you are expected to have a whole number. Why? Because this side length is bigger than this side length. As simple as that. Okay? And by the way, if I used, let's say this one, I'm going to take my one. If you check this one here, it is connecting from here up to there. So it is a diagonal through a rectangle of 3 by 2. Okay, so even here I'll say this is my 1, then this is my 2, this is my 3. Now we have 3, then divide by this one here is a 1. So you still get the same scale factor of enlargement. Okay, that is that. Next, part B. On the grid, draw the image of Roman 1 triangle A after a reflection in the line x is equal to -1. So here the object and the image must be equidistant. Okay, object and image must be equidistant, equal distance. Okay, so must be equidistant from the middle line. X is equal to -1. So you need to first draw that line. X is equal to -1. So this is the one here, and then make it dotted so that it doesn't interfere with our diagram, so that it becomes very clear that this is what you have done on the paper. And sometimes we even add on these such that this is a representation of what? Of a middle line. And you can even label it to become so smart that this is x is equal to -1. So we are reflecting triangle A. The object point here is 2 units from the middle line. That means the image will be 2 units from that middle line on the opposite side. You see that? So that means I will put my point here. Then this one is 1, 2, 3. Then we go 1, 2, 3. So we shall have it here. And then this one is 1, 2, 3, 4, 5. Then you go 1, 2, 3, 4, 5. You see that? So it will be here. Then now you can connect them. You draw here, there, and here. We can shade it, we can leave it, you choose what you want. But when you do some small shading, it looks so beautiful, right? And then, since they have not told us to label it, maybe with a given letter, I can just put B, Roman 1, such that the examiner sees very fast what I've done. And then Roman 2, triangle A, after rotation 90 degrees, center, 1, -2. You see this is rotation. So when you are describing, you say rotation through 90 degrees clockwise, center. You remember this description? Now this is what we are supposed to do here. Now to draw. They have described for us, so we are supposed to do. So look for that point 1, -2. Where is 1, -2? 1, -2 is here. Mark that point, this one here. Then we are rotating A. Okay, now let me use another color. Let's say red. You connect this one here. Okay, connect this one here. Also connect this one here. We are going to bring a protractor. Okay, when you bring the protractor, you can actually use a tracing paper, but since I don't have a tracing paper here, all I can do is to bring the protractor here. They are saying that we rotate this one 90 degrees clockwise. So I need to first do like this, such that this one coincides with that line. Okay, this line, let's say this one here, then 90 degrees clockwise. This one is going to be here. So clockwise we are going like this. So that means the axis which I'm taking is this inner one, which has the 0 here, and then it moves like this. You see that? Okay, now our 90 is here. If I can draw a line, it is here. You see that? Now you count. This one here is a diagonal in. These are how many diagonals? 1, 2, 3. That means even here I'll go 1, 2, 3. That means the point is here. You see that? So having seen that point there, let me take away everything here. So our point is here. Diagonals how many? 1, 2, 3. Then we can also continue to rotate this one. Let it go to this other one here. So we are supposed to look for 90. So 90 is along here. Now you see from this point here, how many squares are there? This is 1, 2, 3, 4, 5. So even here we shall go 1, 2, 3, 4, 5. So the point is here. You see that? So that means we are going to mark our point just here. Then next we rotate this one. It is supposed to come to this other one here. That one there. This one is actually a diagonal. If you can see, it is just a diagonal through how many boxes? 1, 2, 3, 4, 5, 6. So even here we shall go 1. Remember we are going through 90. Isn't it like that? So we must go 5. We must go through 5. Are they 6? Yes. This is 1, 2, 3, 4, 5, 6. So it is here. You see that? So that means we shall mark our point there. Then you can now take this one off, and then you join these points just like that. And then just like before, you can also do a small shading here, and then you label this one as B Roman 2. So that is what we are supposed to have there. Okay. Here you either use a protractor or tracing paper. Question 6 is coming from statistics. They are saying there are 15 giraffes in a group. The table gives information about the heights of the 15 giraffes. They are saying one giraffe has a height of 2.6 meters. Then no giraffe is shorter than 2.5. That means the minimum is this one here. Then the range of heights for the 15 giraffes is 2.3. More than 3 giraffes have the same height. The model height of the giraffe is 3.9. Now, they are giving us the stem and leaf diagram. One of the things you need to know about the stem and leaf diagram is that these numbers that you put here must align vertically. And now, based on what we are having here, this one is a decimal. Even here they have talked about a decimal. So when we are drawing the stem and leaf diagram, we don't put the decimal points. Okay, it is the key that tells us that, for example, here 4-1 represents a giraffe height of 4.1, but the point does not appear in here. Okay, it can be in thousands, something can be in thousands, and we are not going to put these thousands here, but you state it here in the key. That's why the key is very, very important. Okay, so here they are saying use this information in the table to complete the stem and leaf diagram for the group of 15 giraffes. Now, since, by the way, no, when you look at this one here, they said that the range, let me begin with this one here, the range. We know that range is equal to the highest value minus the lowest value. So if the range was given as 2.3, the highest value, do we know it? Was it this one? We don't know it. Okay? But the lowest value, at least they have told us that no giraffe is shorter than the 2.5. So that means this is the shortest. So when you bring this one this side, that means you will get 2.3, then plus 2.5 to give you that highest. So therefore the highest value is 4.8. Okay, and then from the stem and leaf diagram here we see a 7, so that means there is an 8 that we are supposed to put there. Okay, then next they said more than 3 giraffes. Okay, more than 3 of these giraffes have what? The same height. That means these ones will give us the mode. You get it? Because mode is the most appearing what? Number. If mode is the most appearing number, and they said here that the model height of the giraffes is 3.9, that means we are going to have, and they said more than 3. So we shall have 3.9 appearing more than 3 times. You see that? More than 3 times. Let's say we are putting 4 times. Okay? 1, 2, 3, and 4. Okay? First, let me just put those 4. Remember, these numbers must align vertically with these ones here, right? You don't write numbers in the middle of others. Then, one giraffe, they said one giraffe has a height of what? 2.6. So that means I'll write a 6 here. How many giraffes did they give us, by the way? They are 15. So let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means the 3.9 was supposed to appear 4 times. Okay? As simple as that. Question 7 is coming from fractions. They are saying work out part A, 5 over 6 minus 7 over 12. Give your answer as a fraction in its simplest form. Now what I can do is to look for the same denominator. So 6 can be turned to a 12. I just multiply this by 2. So what I do down is what I do up. It's like I've done nothing because the operation I've done here can cancel out, right? So therefore, this is, so what I've done here is what we call getting an equivalent fraction. So this one will give us 10 over 12, then minus 7 over 12. Now, this 12 here is the same, so we just subtract the numerators, and that one gives us 3 out of 12. But 3 goes into 12 4 times. That means our answer is going to become a quarter. As simple as that. Then part B, one whole number 1 over 3 divided by 8 out of 15. Give your answer as a mixed number in its simplest form. So the first thing we do is to change this mixed number to an improper fraction. So here, this one will be 3 times 1, that is a 3, then plus 1, that will be a 4. So it is 4 over 3. Then we are dividing by 8 out of 15. And then from there, we turn this division to multiplication, and then we somersault this one. In other words, we multiply by the reciprocal of this, okay? Just like that. Then 4 goes into 8 2 times. 3 goes into 15 5 times. So meaning we are going to get 5 over 2. And 2 goes into 5 2 times. And then remainder a 1. So 2 whole number, 1 over 2. That becomes our answer. Then question 8, they are saying write 42 as a product of its prime factors. Okay, so you have 42 here. Divide it by 2. You'll get 21. You cannot divide this by 2. Go to the next prime number, 3. Then you get 7 here. Then 7 here. You get 1. So that means 42 is going to be equal to 2 times 3 times 7. As simple as that. Then find the highest common factor of 84 and 70. So here we can use the table, okay, the table format. You have this 84 and then you have the 70. Look for numbers that can divide both. For example, I can use 2. So 84 divided by 2, we get 42. Then here we get 35. Now there is no number that can divide, 2 cannot divide these 2, so you leave the 2. How about 3? 3 cannot go into 35. How about 7? How about 5? 5 can go in here but not here. It's the same as 6. Let's go to 7. Actually, we always use prime numbers here. 2, 3, like that. So we can now go to a 7. A 7 can go into 42 6 times. A 7 can go into this one 5 times. You see that? Now, those are the only numbers that we can divide, because there is no number that is going to divide 6 and 5 except 1. You see that? So that means we are done. So our highest common factor then is going to be 2 times 7. So we get these numbers that have divided both numbers here. We multiply them and then we get our answer, which is now 14. Question 9, part A. I can see algebra here, but they are saying solve this equation here. Now we can see this one is quadratic. So what we can do is to bring everything onto this side and then we form a quadratic equation. So this one is going to be 5x squared, then plus 17x, then minus the 12, which is equal to 0. Okay. Now this is a quadratic equation. You can use the quadratic formula. X is equal to minus b plus or minus to the root of b squared minus 4ac out of 2a. We can use factorization. Let's check factorization. The sum is equal to the middle number here, which is 17. Then the product. So we are supposed to look for two numbers whose product is this 5 times negative 12. We always get the coefficient of the x squared then times this constant here. So it is 5 times negative 12, which is actually negative 60. So two numbers, when we multiply them, they give us negative 60. But when we add them, they give us what? 17. So we have 20 and 3. 20 and 3. But since this one is a negative, one of the numbers must be a negative and then the other must be a positive. So this one can be a negative, this one can be a negative. But since the sum is a positive, that means we are going to take 20 and then 3, because negative 3, 20 plus negative 3, you are getting this 17. So meaning these two numbers you have gotten, then put them in the place of what? 17, and then you factorize accordingly. So we shall have 5x squared minus 20x, because remember this, no, it is actually plus, because this one here is the 20 is positive, and then this one is negative. Then we shall put minus 3x minus 12, which is equal to 0. Now, the terms which were 3 here have now become 4. Then you split this one into 2. You factorize here, then you also factorize here. Now, what is common here? A 5 goes into 20. There is also an x here and also there. That means 5x is common. And then this one divided by 5x, you'll get x remaining. 5x squared divided by 5x, we shall get an x. Then 20x divided by 5x, we shall get a 4. So I'll put plus 4. Now, you don't waste time. This one here, the bracket, you just put it here. Then you ask yourself, what should I multiply with this x to get minus 3x? That is automatically minus 3. So you put minus 3 here. In other words, minus 3 is common here. Okay? And then x plus 4 is common, so I factorize it out. Then here I have 5x. And then minus 3 is equal to 0. So you get this x plus 4, you equate it to 0. Automatically x becomes a negative 4. And then when you get this one here, you equate it to 0. Then our x is going to become 3 over 5. So we have negative 4 and then 3 over 5. Then part B, ax squared plus a is equal to b, where a and b are integers. One solution of this equation is x is equal to 6. Write down the solution of the other. Now, you should know that negative x squared will always be equal to positive x squared. Okay? Will always be equal, because a negative times a negative is always a positive. So if they have given us a positive one here, then the other one has to be a negative. So it will be negative 6. Okay? So negative 6 squared is going to be equal to positive 6 squared. They both give us 36. You get it? Because when you look at this one here, we have one part where there is x and it is squared. So whether you put the negative or the positive, the result is the same. Question 10. We are supposed to solve these simultaneous equations. Okay? Now we can see that the coefficient of x here and also here is not the same. So what we need to do is to multiply through. There are many methods we can use, okay? But I'm going to use elimination. There is elimination, there is substitution, there is matrix method, which is actually not so common. In this paper here, we always use elimination and substitution. Now, what we are going to do, we are going to get this 4x here. I'm eliminating x. This is 3x minus 2y, which is equal to 8. So the coefficient of x here, I multiply it through here. And also the coefficient of x here, I multiply it through this equation. Why? Such that I have the same coefficient of x here that I can subtract, and then the x disappears, then I remain with y. So 3 times the whole of that equation, we shall get 12x minus 15y, which is equal to 39. Then 4 times 3, that will be 12x again, then minus 8y, then this one is equal to 32. Now, do you see that this one is the same? Now, since all of them have the same signs, it is positive, positive, then we subtract. If the signs are different, for example, this one is a negative, then I add such that they disappear. Keep that in mind. So, I'm going to subtract, okay, and after subtracting, here, what do we get? So this one has disappeared. Now we have negative 15 minus 8. You see that? Now this one is going to become a plus. So when it becomes a plus, we shall get negative 15 plus 8. That is a negative 7. So here I'll have negative 7 of y, which is equal to 39 minus 32. That is a positive 7. So meaning y is going to be equal to 7 over negative 7. Automatically, this one gives us negative what? 1. Okay, then now we can substitute in any of these two equations to get the value of x. Okay, so we have 4x, then minus 5 times negative 1. I'm using the first equation, which is equal to 13. Now 4x here plus a 5 is equal to 13. That means this whole thing has to be 13. In other words, this one has to be 8, because 8 plus 5 gives you 13. Now, if 4x is equal to 8, then that simply implies that x shall be equal to 2. Okay, I brought this one this side, it became a minus. You get it? So that is 13 minus 5, and then x becomes, this is 8, then divide by the 4, which gives us a 2. So meaning x is equal to 2, and then y is equal to negative 1. Question 11 is coming from probability. Angela picks a number at random from the numbers 1, 2, and 3. She then picks a number at random from the numbers 4, 5, and 6. She adds the two numbers to find the total. Part A, complete the table to show the possible outcomes. Now, they are just adding them. So this is very easy. Just like 1 here plus the 4, you get the 5. Are we there? Then 2 plus the 4, you get the 6. And then you have 3 plus the 4, you get the 7. You get it? Now, 5 and 1, 6. 6 and 1, 7. 6 and 2, 8. 6 and 3, 9. 5 and 2, 7. 5 and 3, we get 8. So this is what you're supposed to have in the table. Now they are saying part B, given that the total is odd, find the probability that one of the numbers Angela picks is a 3. The total is odd. Now, if the total is odd, the numbers which are odd, what are we seeing? We have 7, we have, yes, this 7, this 7, this 7, then this 9, and then this 5. You see that? How many are they? They are 5. So that means our sample space, if I can write, the sample space is equal to 5. You see that? Because we have seen that there is a 5, there is a 7, there is a 7, there is a 7, there is a 9. So the number in here is 5. Then the event. So in here, we can have they are saying that the probability that one of the numbers Angela picks is a 3. So you go to a 3 here, and then you look at this column of the 3. So in that column of the 3, how many odd numbers do you see there? We are seeing the 7, and we are also seeing the 9. You see that? So I will say that my A, the event, my A here, we are having 7 and 9. So that means that here we are having 2. So probability, remember probability of now that A is going to be n of A over n of S. So this will automatically give us a 2 over 5. 2 over the 5, as simple as that. Then 12 is coming from vectors. V is given as 2, negative 3, find 5V. So 5V, in here we are supposed to multiply all the entries. Okay, so this one will be 5 times 2 and also 5 times negative 3. Many people multiply only with the 2 and they think that is correct. No, multiply that scalar by all the entries in that given vector. So this will be 10 and then negative 15. Then part B, H is this point here, K is this point here, HJ is this one here. Find JK. Okay. Now, when we look at this one here, I'm going to use calculus here, okay? Now, the position vectors here, if H is this point, then that means the position vector of H from the origin, so we say OH, this one is going to be -3, 8. And then the position vector of K, that is OK, this one is going to be -4, 0. Then, after that, HJ, from H to J, and it was given here, is this 7, -2. Now, HJ is actually equal to OJ minus OH. So since I have OH, that means I can get OJ. So meaning OJ is going to be equal to HJ plus OH. You see that? Let me take this one here. So meaning our OJ, because remember in vectors I told you don't need to waste time. You get the last minus the first, okay? Suppose I have this as the vector. Maybe this is H. And then this is the J. That is the vector there, okay? And let's say we have the origin maybe here, okay? Now, for me to go to J from H, I will say this is what? HJ is equal to HO, then plus OJ. You are coming like this, and then like this. So here you are following the same direction. That one is positive, but then here it's negative because you are going in the different what? Direction, the opposite direction. So meaning you are going to have this one as a negative OH. HO is the negative OH. So we can write the positive first and then the negative last. That's why I just say that you don't need to waste time with all of this. You just say the last one minus the first one, okay? So OJ is therefore going to be equal to, what is HJ? HJ is 7, -2. And what else? OH. OH is here, -3. And then 8. So what is this one? 7 minus 3, that will be a 5. And then -2 plus 8, that one will be a 6. Then from there, now we need to find JK. JK is going to be equal to OK minus OJ. So OK is -4, 0, and then OJ is 5. Is it even 5? I think I must have missed here. Pardon me. 7 minus 3 must give us a 4. This one is a 4. So we shall have 4, 6. Now, -4 minus 4, that will give us -8. And then 0 minus 6, that's a -6. Okay. Now, we are having something like this. Move to the left, and then after, move down. Like that. So, we are going to have, this is J, and then this is K. So, we are moving 8 units. 8 and then 6 units. So this is a right angled triangle. That means for us to get JK, we are going to get Pythagoras theorem. Okay, we are going to use Pythagoras theorem. So therefore, the magnitude of JK is going to be the square root, because you get this squared plus this squared, then is equal to this squared. But we need this one here, so we take the square root. Okay, so this one is going to be negative 8 squared, then plus negative 6 squared. And what do we see here? 64 plus 36, which is root of 100. And this one gives us a 10. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.